Welcome to the Explainer. Today, we're diving into the secret life of something so fundamental to robotics, you probably overlook it all the time: the wheel. You're about to find out that for a robot, the kind of wheel it has isn't just a part, it's the whole game plan.
So, when you picture a really advanced robot, what do you think makes it so effective? What's its secret weapon for getting things done?
You might think it's the brain, right? A super powerful computer crunching tons of data. Or maybe it's the eyes, all those complex sensors that let it see and map out the world. And yeah, those things are absolutely critical, but that's not where the story begins. No, the real foundation of how a robot actually moves, interacts, and achieves its goals, well, it all starts with something much older and honestly a lot more basic. That's right, the wheel. It turns out how a robot moves is just as important as how it thinks. And the specific type of wheel it's built with, that choice pretty much defines its entire destiny. So, okay, why are we focusing so much on wheels? Because for a robotics engineer, choosing the wheel isn't the last step. It's one of the very first and most important decisions they have to make. And this quote right here just nails it. The wheel sets the stage for everything else. Can the robot stay balanced on a ramp? Can it quickly dodge something in its path? Can it navigate a crowded room? The answer to all of that starts right at the point where the rubber meets the road or the floor. So let's start with the one we all know and love. If your only problem is how do I get from point A to point B on a nice flat surface, then the answer is almost always going to be the good old standard wheel. I mean, we see this one everywhere. It's on our cars, our shopping carts, you name it. It's designed to do one thing incredibly well: roll forward and backward. Its genius is just how simple and efficient it is. Now, what's so interesting here is that its biggest strength is also its biggest weakness. That simple design makes it super energy efficient, with almost no friction. But that same simplicity means it has absolutely no way to move sideways, and it's pretty useless on bumpy ground. So the takeaway is, simple is great, but only in a simple world. And that's exactly why you see standard wheels ruling the world of warehouses and factory floors. Any huge, flat, predictable space is basically the perfect kingdom for a robot on standard wheels. But even a simple robot needs to be able to turn, and that's where standard wheels need a little help. They're often paired up with caster wheels, the little swiveling ones. They help make turns smoother, but they're really just a patch. They don't solve the bigger problem of maneuverability. Which brings us to the next big challenge. Think about a robot in a skinny hallway or moving around beds in a crowded hospital room. It can't just do a three-point turn. So how in the world does it move sideways? Well, this exact problem led to some of the most mind-bendingly clever designs in robotics. We're talking about wheels that were literally invented to go sideways. This is where robots got a superpower: agility. So first up, meet the omni wheel. Now, you gotta look closely at the edge of this thing. It's not one solid wheel, it's covered in these tiny little rollers. Those rollers are the magic trick. They let the entire wheel slide sideways, letting the robot just glide left and right without even turning. And then you have its even crazier cousin, the Mecanum wheel. Notice the huge difference. The rollers are angled at 45 degrees. Now this is pure genius. By spinning each of the four wheels at different speeds and in different directions, a robot can move in any direction: forward, backward, sideways, and even diagonally, all without ever changing the way it's facing. So, if you're a robot designer, which one do you pick? Well, here's the breakdown. Omni wheels are a little simpler to control, which is great for service robots that just need to slide around people. But Mecanum wheels, they offer total freedom of movement. That's a total game changer for robots in super cramped warehouses. But man, the computer program to control them is incredibly complex. Okay, so we've pretty much figured out how to get around indoors. But the real world isn't all polished concrete and smooth tile. What happens when a robot's mission sends it out into sand, mud, or over a pile of rocks? Yeah, for the great outdoors, you need a totally different approach. You have to be willing to trade all that fancy, nimble movement for just raw, unstoppable traction. And that's when you call in the heavy hitters: tracked wheels. Yep, just think of a tank. Instead of a few small points of contact, the robot spreads its entire weight across a huge surface area. That is the secret to their incredible grip. But you knew this was coming. There's always a trade-off. As you can see, you get absolutely phenomenal traction on pretty much any surface you can think of. But the price you pay for that is a big hit to your speed and your energy efficiency. Tracks are heavy, they cause a lot of friction, and they can tear up the ground. They are a brute force tool for a brute force job. And that's why these are the go-to for robots in the most extreme places you can imagine, both on and off this planet. From military and rescue robots here on Earth to the rovers exploring the surface of Mars, when you absolutely cannot afford to get stuck, tracks are how you get it done.
So, we've covered the big 3 types of wheels you see out there today. But engineers are never satisfied. They're always pushing the envelope. So what's next? Where do we roll from here?
And this is where things start to feel like science fiction. People are working on some wild stuff. We're talking about spherical wheels. Just imagine a robot gliding around on a giant ball bearing, able to move in any direction instantly. Or a hybrid wheel legs that can roll on a flat surface and then sprout legs to climb stairs. They're even looking to nature, trying to design wheels that can mimic how an animal crawls or climbs to get over really complex obstacles. So if there's one thing to take away from all of this, it's that there is no single best wheel. It all depends on the job. From the simple standard wheel for the warehouse, to the slick omni and Mecanum wheels for tight corners, to the tough-as-nails tracks for rugged terrain, the wheel is always chosen to match the world it has to conquer. And that really just leaves us with one final, exciting question. As we keep sending robots to places we've never been, from the bottom of the ocean to planets light years away, what kind of brilliant, bizarre, and revolutionary new wheel are they going to need to roll on?